Today we're going to take a look at a pretty fun, pretty scary looking problem. We have, in parentheses, 1 over x minus x squared minus 13 times 1 over x minus x plus 40 equals 0. Now, at first, there probably is a line where you can multiply 1 over x minus x times 1 over x minus x. You multiply all that out, distribute the 13 here. That probably could happen. That would be quite a process, but I'm sure it's possible. And then you'd have to multiply everything by the x to give it, like, it'd get pretty messy pretty quickly. Here's how I'm going to approach this. I'm going to use substitution. I'm going to call u equals 1 over x minus x. And the reason I can do that is because, look, I have 1 over x minus x here, 1 over x minus x here. So if I replace that, what I'm trying to do, like my whole thought process is here, is if I'm just trying to factor a trinomial, essentially. That's all I'm trying to do. Where these visuals of 1 over x minus x, like that makes things a lot more difficult because we have a lot more to worry about. But if I just replace those with some variable, u, we'll call it, then I could just replace this as u squared minus 13u plus 40 equal to 0. Now it's just a quadratic, and I could factor that. That's all it is. So don't let this 1 over x minus x like completely throw you into this tailspin of like, wow, this is going to be really hard. Let's just substitute out that 1 over x minus x, and then we'll go through and factor, and then we'll have to resubstitute, do some simplification, see what happens, and then we'll just work from there. But just take it step by step. Like, don't start freaking out just because you see that really crazy variables and everything inside those parentheses. So just start working through it, see what happens. All right, so let's now factor. What I'm looking for is I'm looking for two numbers that multiply to 40 and add up to negative 13. So it's going to be u, and we want two numbers that multiply to 40, positive 40, adding up to negative 13. So I know 8 and 5 is going to multiply to 40. 8 and 5 add up to 13, but I want them to multiply to a positive and add up to a negative. So that's going to be negative 8 and negative 5 equal to 0. And what do? We now set these two terms equal to 0. So u minus 8 equal to 0. This is no different than any other solving when you have to factor. And then we say u is equal to 8. U is equal to 5. Now we have to do some work. Now the real, like, okay, this is going to get, like, that part, the substitution, as long as you could see that substitution, this whole first half was pretty manageable, just factoring. Now we have to resubstitute. So now we have to put back what u is equal to. So let's see. We're going to have 1 over x minus x equal to 8. And 1 over x minus x equal to 5. Move this down. Now we have to just solve both. So over here, I'm going to multiply by x. So I'm going to have 1 minus x squared equal to 8x, because if I do that, that's 1 over x is 1. And I got to do that, so that's minus x squared equal to 8x. And I'll just do one at a time. I'm going to now have to solve this. So now I'm just trying to solve. So I'm going to add the x squared over to here. I'm going to subtract 1 also over here. So I'm going to have 0 equals x squared plus 8x minus 1. And then before I go too far, now I'm going to go to my other one, 1 over x minus x equal to 5. Let's just clean that up. So I'm going to do the same thing. I'm going to multiply by x. So I'm going to get, again, 1 minus x squared equals 5x now. Do the same thing, add the x squared over, because I'm trying to create a favorable scenario here. So 0 equals x squared plus 5x minus 1. And we still, like, we're still trying to figure out what x is. So let's go back to the beginning. It wants us to solve. We want to know what x is equal to make this a true statement. And we had to do a lot of fancy footwork. Now we're just down to even this point. So we're not even out of the woods yet. Now I have these quadratics where these trinomials, where I can't even factor those. So I'm going to have to use quadratic formula now. So now is this extra layer I go from this really cool substitution, like, oh, that's a cool discovery there, I found that. And then now I'm having to use quadratic formula. So quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. I'll set up this one. Negative b plus minus square root of b squared minus 4ac all over 2 times a. Quadratic formula there. Now what? Okay, well, we have some work to do inside of the radicals. I have 8 squared is 64, and then, so this is 64 here, minus 4 times 1 times negative 1. So that's going to be negative 1 times 4, which is going to be negative 1 times 1 is 1, 1 times negative 4. Negative 1 times 1 is negative 1. Negative 1 times negative 4 is positive 4. So that's going to be plus 4. So let me just, you know what, before I make a mistake here, let's just clean this up. I'm going to have this as 64 plus 4 over 2. And then I'll even go over here, just kind of work both of these through. So this is going to be 25 plus 4 all over 2. Oops. 64 plus 4 is 68. So I'll have negative 8 plus minus square root 68 divided by 2. I'm going to stick with this one in blue for a second. I have the square root of 68. Square root of 68 is 4 times 17. So I'm going to simplify that radical. So square root of 68 is 4 times 17. Square root of 4 is 2. So really this becomes 2 root 17. So this is negative 8 plus minus 2 root 17 all over 2. I'll go to the second one in a minute. Let's just finish this one off. From here, you could take out a 2 where this, so if I take out a 2, so let me just do it right here. I'm going to take out a 2. So this becomes negative 4 plus minus root 17. And then I have that over 2. So then the 2 is going to cancel there. So I'm left with negative 4 plus minus square root of 17. And I think we would be good from there. And then over here, negative 5 plus minus square root of 29. Can't do anything with that, not like the last one. So I would leave that one as is. So pretty crazy here. A lot of steps that we had to account for. Let me look back at this sequence right here. Let me just make sure we're all good. So 4 times 17, square root of 4 is 2. Take out 2, so that's 4, and then 17, and then 2's are going to drop out. Yeah, I think we're okay there. And this one, 29. Yeah, 29 not helping us. So those would be our solutions. Yeah, really, really good problem. Like, this is addressing a lot of different abilities and skills on this problem. Let me just go back and just do a little short recap here. So again, finding this substitution, that is the key. And noticing that these are the same, 1 over x and x, 1 over x minus x. Those are the same, so I'm able to do that substitution. But then once you do that, like, this is not the answer. Like, oh, my answers are u in 8 and 5. Like, no. That's just before we have to now substitute. And then we have to start solving all over again. So that's another step to it. So then you have to resolve, and I have this unfavorable scenario where I have to use quadratic formula on both of those, and it gets a little messy. Simplifying radicals here, and then we get our answers after all of that very, very fancy footwork. But yeah, this is a good problem, and this is the type of problem that I would say do not let yourself get intimidated by this type of problem. Like, just look for something that can help you, look for that substitution, and then just start working through, and hopefully things just kind of fall into place. So, fun problem today.